Miss Mayhew here, and I'm going to go over osmosis with you guys. So we've covered several different types of transport of molecules across the membrane. Today we're going to focus specifically on the movement of water. This is a type of passive transport, so it's kind of like a subsection of 5.2. Now, osmosis is the diffusion of water across membranes through special channels. Now, this is going to be moving in the direction that it wants to, so down its concentration gradient. So depending on the concentration of water molecules on either side of the membrane, the water is going to move down its concentration gradient. So from a concentration of high water to a low water concentration. This is where it gets a little confusing. You have to focus on the water molecules and the concentration of the water. The reason that's tricky is because, for the most part, when people are talking about concentrations, they're talking about solute concentrations. So, the higher the total solute concentration, the lower the concentration of water molecules. And vice versa. The lower the concentration of the solute particles, the higher the concentration of the water. Now, one formula that we use in AP Biology is the formula for osmotic pressure. Now, osmotic pressure is the pressure that must be applied to a solution to prevent the flow of water across a membrane by osmosis. Okay, this osmotic pressure is represented with this symbol here and can be calculated by multiplying the total solute concentration by the gas constant and the absolute temperature. When we're talking about concentration gradients and osmosis, we're talking about them comparatively. So we're going to be comparing one side of the membrane's concentration to the other side of the membrane's concentration. Now, the higher concentration of a solute or substance on one side of membrane represents stored energy. Okay, it's kind of like potential energy because it wants to travel to the other side. Now, a membrane allows water but not solutes to pass through. When this happens, the net movement of water molecules will be towards the solution with the higher solute concentration, meaning the lower concentration of water molecules. So, the water will be moving towards the side with the higher solute concentration, but that reasoning is because you have a higher solute concentration and a lower concentration of water. Water is going to move from a high water concentration to a low water concentration. Now, the terminology that we use to compare two solutions are these that follow. Hypertonic solutions have a higher solute concentration. Okay, isotonic have equal solute concentrations, and hypotonic solutions have a lower solute concentration. Remember, we're talking about the solute concentration when we use these terms. Now, the reason osmosis is important to biology is because osmosis can modify the shape of cells. Okay, in animal cells, because they only have a cell membrane, they can either shrink or shrivel, or they can expand and possibly even burst, depending on the type of solutions that they're in. Plant cells, because they have a cell wall, will still change shape, but they're going to, that cell wall is going to provide some structure for it. So like what was in that picture, the concentration of the solutes in the environment that the cell is in is going to determine the direction of osmosis in all animal cells. Okay, again, depending on the concentration of water or solutes, the water is going to move from an area of high water concentration to low water concentration, or low solute concentration to high solute concentration. In other organisms that have cell walls, this limits the volume of water that can be taken up. Animal cells, because they only have a membrane, will take up until they burst if that's the case. Otherwise, if there's a cell wall, that's going to limit the bursting and only allow a certain amount to be taken up. This is where turgor pressure comes in. Turgor pressure is that internal pressure that is built up against the cell wall, and that's what prevents more water from entering the cell. Now, water is able to cross the membrane at a faster rate than simple diffusion. That's for two main reasons. One, water might hitchhike with ions such as sodium as they pass through ion channels. The second reason is there are aquaporins, which are protein channels embedded in the cell membrane that allow large amounts of water to move along the concentration gradient. So let's summarize osmosis in one page. So what I have here is obviously my cell membrane. I've got my phospholipid bilayers with their tails facing the inside, and embedded in this phospholipid bilayer, I have a protein. This protein is called aquaporin. Aquaporin is the protein channel that allows water molecules to move across. Now, this is a form of facilitated diffusion, so these water molecules are going to be moving with their concentration gradient. So from a high water concentration to a low water concentration. Okay, now where that starts to be tricky is we often refer to solutions in comparison with each other in terms of their solute concentrations. So remember, anywhere you have a high solute concentration, you're only going to have room for a low water concentration. Wherever you have a low solute concentration, you're going to have more room for a high water concentration. Okay, remember, osmosis is the movement of water. So those water molecules are going to move from where there's a higher concentration of water molecules, to where there's a lower concentration of water molecules. Now, because this is moving with the concentration gradient and the way that it wants to go, this doesn't require any energy. It's important to remember that. This is a form of passive transport. Now, that's all I have for you guys on osmosis. If you have any questions, make sure you ask your teacher. Bye!